In this example, we want to show that the given vectors are an orthogonal set. We want to use it to construct an orthonormal basis. Okay, we can call these vectors maybe v1, v2, and v3, just for the purpose of talking about them. To verify that they're an orthogonal set, we need to show that v1 dotted with v2 is 0, v2 dotted with v3 is 0, and v1 dotted with v3 is 0. Well, v1 dotted with v2 that's -2, 1, 3, 0 times 0, -3, 1, -6. So 0, -3, +3 is 0, 0. It is in fact 0. v2 dotted with v3 is 0, -3, 1, 6 times -2, -4, 0, 2. So we've got 0, 12, 0, -12. So 12 minus 12 is 0. And we're going to find the same thing, v1 dotted with v3. Right, we've got -2, 1, 3, 0 times v3 -2, -4, 0, 2. So we've got +4 minus 4 is 0, then 0, then 0. So we've got 0. So they're orthogonal. To be orthonormal, we need them to be unit length. So our E1, we'll call it, will be in the direction of V1, but of unit length. So it'll be 1 over the length of V1 times V1. So the length of V1, 2 squared is 4, plus 1 is 5, plus 9 is 14, so 1 over the root of 14 times V1, -2, 1, 3, 0. Okay, next, E2. That's the vector in the same direction as V2, but of unit length. So V2, the length here is 0 squared is 0, plus 9, plus 1 is 10. 10 and 36 is 46, so 1 over root 46. Okay. Times V2, which is 0, -3, 1, -6. Find the E3 is 1 over the length of V3 times V3. So the length of V3, 2 squared is 4, plus 16 is 20, plus 4 is 24. 24 is divisible by 4, so we can take that out in a second. -2, -4, 0, 2. So it's 4 times 6, so that's going to be 1 over 2 root 6 times -2, -4, 0, -2. If you really want to be clever about this, you'll notice that each of these entries is even, so we can factor a 2 out of that vector, divide out the 2 in front, you get 1 over root 6 times -1, -2, 0, negative 1. And so your E1, E2, and E3 will form an orthonormal basis for the span of this set in R4.